Hello. This example is where we're going to start solving radical equations. Now, a radical equation, spelled like this, is any equation that effectively has a radical symbol in it. Now, a radical symbol, in case you're not aware yet, it's the root symbol here. Now, this root symbol, while it's called a radical, whatever is underneath is called the radicand. And also, every radical has what's called an index, and that index is whatever's written right there. Now then, in order to solve this type of equation, we're going to have to get rid of this radical, the root symbol. To do that, we're going to use this theorem. It says all solutions to P equals Q are also solutions to P to the n equals Q to the n. Look at this theorem. It's telling us that every solution to P equals Q is also a solution to P to the n equals Q to the n. Notice what it is not saying is that every solution to P to the n equals Q to the n is also a solution to P equals Q. That means that if you use this theorem, what you can do is you can take both sides to some power, but you have to remember to check your solution to the original equation, because there could be solutions introduced whenever you square or cube both sides that are solutions to that resulting equation that were not solutions to the original. Now let's use this information. There are a few different steps for solving a radical equation like this. The first step is to get a radical by itself. Okay. To do that, look at x minus the square root of 15 minus 2x equals 0. I want to get this radical by itself, and the easiest way is going to be to add the square root of 15 minus 2x to both sides. And what that's going to do is that's going to give me, let me just make a line here, that's going to give me x equals the square root of 15 minus 2x. Now then, the second step is to take both sides to some power. Now it depends on what the index is for the radical. Now in this case there's an understood 2 right here. And because there's an understood 2 right here, we're going to square both sides. Notice that the left-hand side is just x squared. But look at the right-hand side. We have the square root of 15 minus 2x squared. But remember that a to the m over n is equal to the nth root of a all to the mth power. Notice that that's what we have here. So if I just look at the square root of x or something like that, if I had the square root of x squared, that would mean x to the exponent of 2 divided by the index of 2. And 2 divided by 2 is just 1, so that just leaves me with x. It's whatever's underneath the radical. In other words, it's the radicand. So that means that x squared over here, because it would just squared that, but squaring this gets rid of this radical and the square, so we have whatever the radicand is, which in this case is 15 minus 2x. The third step is to solve. Now this is just a quadratic equation, and you already know how to solve this. So what we're going to do is we're going to get this into the general form. So I'm going to add 2x and subtract 15 from both sides, and that's going to give me x squared plus 2x minus 15 is equal to 0. Notice that this is just a regular quadratic equation, and I can solve this at least easiest by factoring. Notice I didn't tell you one way or the other to solve this, so you get to choose how you want to solve this. So factoring is easiest. If you wanted to, you could use the quadratic formula, you could use completing the square, pretty much anything that we've gone over. Now the factoring, we need an x here and an x here. This minus here tells me that they are opposite signs. One's positive, one's negative. And the question that I ask myself is, what multiplies to 15 and subtracts to give me 2? Well, that's 5 and 3. 5 times 3 is 15. 5 minus 3 is 2. Fantastic. The question is which one goes where, because these are opposite signs. It does matter. Because this middle term is positive, that means that the larger of the two, 5 and 3, needs to be positive, which means 5 must be positive, and 3 will be negative, with a 0 over here. Now I'm going to use the zero factor property, which means that x plus 5 equals 0, or x minus 3 equals 0. Subtract 5 from both sides, so x equals negative 5. Add 3 to both sides, so x equals 3. These are just proposed solutions because they're just solutions to the quadratic equation, at least a guaranteed. What they're not guaranteed to be are solutions to the original radical equation. Therefore, we need to actually check them, and if you don't check them, you can't guarantee that these are solutions, therefore they're incorrect until you've actually checked them. So, if we check, we have x minus the square root of 15 minus 2x equals 0. I'm going to replace x to be negative 5 first. And that's going to make this negative 5 minus the square root of 15 minus 2 times negative 5. And that's going to be equal to 0, we hope. Now, what is negative 2 times negative 5? Well, that's positive 10. 10 plus 15 is 25. And what's the square root of 25? Well, that's 5. That's going to give us negative 5 minus 5 equals 0. Is negative 5 minus 5 equal to 0? No. It's negative 10. Now you do need to write down this last little step here just to show that negative 10 does not equal 0. So I'm going to put an x there. What that means is that we're going to reject the negative 5. Now I'm going to take this 3 and plug it into this equation. That's going to give me 3 minus the square root of 15 minus 2 times 3. And that's going to be equal to 0, we hope. Again. So negative 2 times 3 is negative 6. 15 minus 6 is 9. And the square root of 9 is 3. So that's going to give me 3 minus 3 equals 0. Does 3 minus 3 equal 0? Yes. So 0 equals 0. Fantastic. That's an identity. Therefore, 3 is in fact the solution. So our solution to this original radical equation is x equals 3. I will see you on the next example.